So one for A and B, we're just talking about how a graph goes from left to right. Is it increasing, decreasing? What do the bumps of the graph tell us? And then here is a topic that you would explore more in a calculus class. It is called the average rate of change. Now, the average rate of change is really just the slope between any 2 points on a graph. Okay. So if you're in a calculus class, we're exploring more of the relationships from two spots on the graph. We actually are going to use the slope formula, y2 minus y1 over x2 minus x1. But we usually use it in function notation. So it's usually f of x sub 2 minus f of x sub 1 over x2 minus x1. So it's just a slope formula. The thing that gets confusing is your graph is not linear, so you think, well, what slope? In that context, it is the slope of the line that connects the points. So I have a parabola here, okay? And if you look, this point right here, that point right there is the point 0, negative 2. And this point right here is the point 3, 1. And if I asked you to find the slope on the interval from 0 to 3, those are the points we would use. Sorry, that looks so yucky. So if we're trying to find the slope on the interval from 0 to 3, we have to find what is the point at 0, 0, negative 2 for this one. What is the point at 3, 3, 1, and that's what we're going to use. So we just use those points. Now, when you're doing it, you usually call the leftmost point x1, y1. Those look so good. And the other point x2, y2. Okay? Because we're going from left to right on the interval. But slope, it's kind of interchangeable, so it's not a big deal one way or the other. But if we do the slope formula using the points given, f of x sub 2 is 1. F of x sub 1 is negative 2. So remember, you're always subtracting in the slope formula. You're subtracting that second piece, so make sure you switch its sign. And then the x's are 3 minus 0. Now, the way to tell you're doing it right, this should be a point. 3, 1 was a point. This should be a point. 0, negative 2 was a point. And then if you do the math, that's 1 plus 2, or 3, over 3, or 1. So the slope of the line that connects those points is 1. That is the average rate of change on the interval between those 2 points. So if you have a graph, you just find this x value, what is the point? In this case, 0, negative 2. And this x value, those are x's. So these are x's. Those are x's on the graph, okay? So now let's look at one where we don't know the picture of the graph, but we have a function. So and that's the ones that you're going to do today in your homework. So our x1, these are x's. So this is x1, and this is x2. I start at the x value of negative 2. I end at the x value of negative 1. That's an interval of x's. So all you're going to do to find the average rate of change on that interval is what is happening at negative 2, what is happening at negative 1. I need a point. So I need the function value at that point. Okay, so if you plug in negative 2, be careful. It is the opposite of negative 2 cubed plus 3 times negative 2. Always use parentheses. That will help that you don't do something funky. Okay, let's put the little x1, x2 up here. Okay, so negative 2 cubed is negative 8. But there's a negative in front of that, so the opposite of negative 8 is 8. Minus 6 is 2. So technically, that is the point. I plugged in negative 2, I got out 2. Now let's plug in negative 1. We get the opposite of negative 1 cubed plus 3 times negative 1. If we think about the same logic, we got 3 negatives there is a negative. Another negative is a positive, so that's positive 1 minus 3 or negative 2. So that's the point negative 1, negative 2. Now, as soon as you have the points, you're ready to do the slope formula, okay? Because this is x1, y1. This is x2, y2. So you just plug them in so that you have a point, and you do the slope formula from back in Algebra 1, okay? So it's going to be y2 minus y1 over x2 minus x1. Or you can use function notation, doesn't matter. Okay, so y2 was negative 2. Y1 was 2. So it's negative 2 minus 2. X2 was negative 1 minus x1, which is negative 2. Now you're always subtracting that little back piece. So always be careful when you're subtracting. So that's negative 4. This will end up being negative 1 plus 2. So that's going to be 1. Or your slope between those 2 points is negative 4. So what does that mean? Well, if you go on to the graph, negative x cubed plus 3x, here's how you check your work. Was it plus 3x? Was that it? Is that the equation? Is that right? And then, I don't know why it's acting so wonky. What was our first point? Negative 2, what did we get as a value? Negative 2, 2? Yeah, we hit the graph. You're good. And then negative 1? Negative 1, what did we get as a value? Negative 2. Do you see how if you were to connect those, see how the slope, if you drew a line between those 2 points, would be down, it'd be negative. And that's what that means, okay? So it makes sense that what we got is correct, okay? Okay, let's do it one more time. So our x1 is negative 1, our x2 is 2. We got to plug those in. So we're going to do f of negative 1 and f of 2. You just plug them in, see what the values are. Watch when you plug them in, especially when you plug in a negative. Are you plugging them in correctly? So that's going to be negative 1 to the 4th minus 6 times negative 1 squared. Sorry, I wrote that so yucky. Negative 1 to the 4th. Now, if we take a negative to an even power, it becomes a positive. So that's positive 1. This becomes positive 1 times negative 6 is negative 6 for a value of negative 5. So if you're not plugging them in right, it will, hurt you. So just be very careful of how you use order of operations. Now let's plug in 2. This is going to be 2 to the 4th minus 6 times 2 squared. 2 to the 4th is 16. This would be 4 times 6 is 24, so minus 24 is negative 8. So now we're ready to use our slope formula. If you like to actually rewrite it as points, this would be the point negative 1, negative 5. This would be the point 2, negative 8. So you can write it as points if that helps you use the slope formula correctly. So it's really your decision. Okay, so we get the slope is negative 8 minus negative 5 over 2 minus negative 1. Okay, you can see this is our second pair, 2, negative 8. This is our first pair, -1, -5. The x's should always be on the bottom. The y should always be on the top. So this is going to be -8. My pencil wakes up here. This is going to be -8 plus 5. This is going to be 2 plus 1. You'll get -3 over +3, or a slope of -1. Now, how could you check your work? Well, you could graph that into Desmos. Wait, there's a plus 4x there. Oh, I'm so sorry, goodness gracious. Do you see the plus 4x that I totally ignored was part of it? Oh, let's go back. Okay, so if I plug in -1, that'd be plus 4 minus 1. It'd be, I'm so sorry, 1 minus 6 minus 4, which is -9. I'm so sorry. This was 16 minus 24 plus 8. Is that 0? Yeah, okay. Now, if we use the entire function instead of just part of it, goodness gracious. Okay, so let's do it again. So it would be 0 minus -9 over 2 minus -1. Okay, so this should be a pair 0 with 2. See, 0's with 2. This should be a pair -9 with -1. So it's good. And then that's 0 plus 9 is 9. That's 2 plus 1, or 3. Our slope is +3. So if we look to the average rate of change between those 2 points is positive, so it's going uphill on that, in that region of the graph. Okay, so that is your notes for today. Do you want to do the first one from the homework together? Yeah. Okay. So the homework, it's just calculations. Okay, let's start with, and it's pretty repetitive, so why don't we just do the evens, okay? I'm going to do 34 with you. Okay. So our interval that we're looking for the average rate of change are the x values from -1 to 3. So this is your x1, this is your x2. So for 34, we've got to plug in into our g function -1, and we've got to plug in 3. So you're just plugging those x's into the function to find out what the matching y's are. If we plug in -1, and don't forget half the function, Mrs. Hott, it's -4 times -1 squared plus 3 times -1 minus 4. You got to be careful with the order of operations. So we get -4 minus 3. Oh, no, I have a parenthesis there. Let's see, let's make sure Mrs. Hott isn't losing her mind. -4 minus 3 minus 4, which is -11. Okay. Now let's plug in 3. If we plug in 3, we get -4 times 9 plus 3 times 3 was 9 minus 4. What is that? -36 plus 5, which is -31. Okay. Now that we have our points, now let's talk about our points. I plugged in -1, I got -11. I plugged in 3, I got -31. And did I do that right? 9, yeah, I just plugged, yeah, I think so. Yeah, okay. So now that we've got our points, it's just the slope formula. So your average rate of change, make this x1, y1, this x2, y2. So we're just plugging those into the slope equation. So it's -31 minus -11. So that's the difference of the y's over the difference of the x's. 3 minus -1. Now the main important part about using the slope formula, these two should be a pair. 3 and -31 are. These two should be a pair, -1, -11. Okay, so that is going to be -31 plus 11 This one's going to be 3 plus 1, which is negative 20 over 4. The answer is negative 5.